Hello friends, welcome to Dr. Sai Physiology Academy, Dope Proficient. This is the place where we make the learning of physiology easy, exciting, and effective. Thank you for joining me. And if you're new to this channel, you're especially welcome. And if you love the content that we share, kindly click the like button and also the subscribe button. And don't forget to turn on notifications so you don't get to miss any new content that we drop. Now let's get started. So now we are talking about mechanical properties of muscles. Muscles are mechanical agents, ability to generate force, physical force. And there are some things you need to know about muscles, about 6 properties, 6, 7 we're going to discuss. And we're just going to start with one very important concept that is called the motor unit. Number 1, because now, what do we mean by motor unit? Mechanical properties. That for muscles to contract, okay, muscles contract in groups. Are you listening? Muscle fibers. Now, you know a muscle fiber, okay, is one cell. But look at what happens. One neuron can supply several muscle fibers, can supply several muscle cells. So the number of muscle fibers or muscle cells supplied by one neuron is known as a motor unit. So if 50 muscle fibers are supplied by one neuron, that group is known as a motor unit. They will contract together. They will do everything together. Because you know why? When a neuron is giving off its axon, its terminal branches at the end of the axon, it has different branches like this, okay, that supply either another nerve or a muscle, in this case a muscle. Okay, so sometimes this one neuron can be supplying different muscles. So all these muscles grouped together, supplied by one neuron, is known as a motor unit. Why is this important? Now, do you know that different kinds of muscles have different sizes of motor units depending on the function? Now, very fast muscles that perform very fast movement, for example, the fingers for fine touch, fine movements, you have about 3 muscle fibers, okay, 3 muscle fibers per neuron, okay. Muscles of the fingers, fingertips, just 3 muscle fibers, they form a motor unit. One neuron is supplying just 3. But in the case of slow, larger muscles, like muscles of the legs that are used for running, okay, you have up to 2,000 muscle fibers that make up one unit, that are supplied by one neuron. Okay, so you see the vast difference. The motor unit for different kinds of muscles are different. So you need to just understand that, a motor unit. Now let's go over to the next one. There's something called muscle twitch. You know, the common use of the term twitch. Oh, the muscle is twitching. It's actually referred to involuntary contractions of muscle, which actually is muscle spasm. But when we are referring to a twitch, we're referring to something different in physiology. It's something different, it means something different. Okay, so a twitch contraction actually is the contraction of one muscle fiber. Do you understand that? A muscle twitch, the contraction of one single muscle fiber as a result in response to one single action potential. That is a twitch, a contraction in response to one action potential. Do you understand? So you have something like this, tension length. So it goes like this. So when action potential supplies the muscle, it will contract and relax. So the beginning of contraction to the end of relaxation is known as twitch duration. Okay, so fast muscles have a short twitch duration, okay, while slow muscles have longer twitch duration. Do you understand that? Twitch duration. Then there's another thing called a latent phase or latent period. Okay, is the period between the activation of the nerve, that's the action potential, comes from the nerve, and the onset of contraction. Okay, action potential enters the nerve that is supplying a motor. You know, the nerve that supplies a muscle, skeletal muscle, is known as motor neuron. Okay, motor neuron. So when action potential enters the motor neuron, the time in between that coming of that action potential and the time it will transfer, all those acetylcholine will be transferred into the space neuromuscular junction and now bind and now develop action potential in the muscle, and contraction will begin. That period is known as latent period. Okay, it can differ in different types of muscle. It's good you know that. All right, so that's what you need to know about that. Then something even more important that you need to know about the properties of muscles is what is known as summation. You might have already had an idea about what summation is from even nerves. Nerves, they have their own summation. But in muscles, it's something very interesting. Now we are dealing with contractions. Okay? A muscle can contract, a skeletal muscle can contract like this. And before it will finish relaxing, another contraction, there's another stimulus again, and another contraction will begin in the same muscle. Okay? And it will contract again. It has not finished relaxing, and it will contract. This one is about to relax, but before it will finish its relaxation, another contraction, another contraction, another contraction. Look at what is happening. So what happens is that summation is the addition of new contraction before the complete relaxation of the previous contraction. And what is the implication? Is that there will be increasing force, because this one has not finished relaxation, another contraction has happened. So they will sum up together. The intensity, the force of the previous one that has not finished will be added to the next one. That one has not finished to be added to the next one. So it will continue to increase like that. If it's happening in one muscle fiber, the summation is known as temporal summation, based on the increasing frequency of action potential and stimulation. Increased frequency of stimulation will cause increasing summation of the contraction that doesn't allow it to finish of one. So it's called temporal. Okay, temporal summation. Then you can have additional contractions from other muscle fibers that they are coming from other motor units, okay, to make up one whole contraction that is summing up to one contraction. That one is called spatial. okay, is the addition of more contractions to an already existing contraction from other muscle fibers. Do you understand it now? Spatial, but temporal is the addition of contractions in the same muscle fiber. So that is summation. Now there's another thing related to summation that is known as tetanus. Have you heard of tetanus before? You heard of tetanus, okay, as it relates to a disease state. Someone has tetanus from a bacteria, tetanus, okay? But in this mechanical property, tetanus refers to something different, okay? So what is tetanus? It's related to this summation. Now look at what happens. Now you see that in this one, it's not relaxing. Relaxation has started before another one comes, okay? But the relaxation does not end before another contraction comes. Now what happens in tetanus is that the frequency of contraction, the frequency of successive contraction is so high that it doesn't even start relaxation at all. One contraction has started, it doesn't start the process of relaxation before another one adds up, and another one adds up. It doesn't reach relaxation, another one adds up. So it goes like this straight. So it's a fusion of contractions based on rapid frequency of stimulation. High frequency of stimulation will cause a total smooth fusion. Now they are not fused, you can still see separation, just that they are not relaxing fully in this temporal summation. But in tetanus, there's a fusion of the contraction to form one whole contraction, and when it reaches its maximum tension or force, there is now a plateau. Then before relaxation comes in. You see that normally if the one twitch happens, it will be like this, okay, to be small like this. One twitch will just be small like this. But tetanus, instead of adding like this to make it high, it just fuses everything high like that, and it goes like this. It's called tetanus, okay? It's a fusion based on rapid frequency of contractions. Okay, so we have three other properties, very important things we're going to mention, okay, about the mechanical properties. Are very interesting, so don't go anywhere after this break. All right, you're welcome back. Now the fourth one we're going to be dealing with, fourth property, is something called treppe. T-R-E-P-P-E, treppe. It's also known as staircase phenomenon. Staircase phenomenon, or sometimes you can call it Bowditch phenomenon, from the man who first discovered it, Bowditch. Now what do we mean by this? It was first studied in cardiac muscles. Okay, it has some similarities with summation, but it's different. Summation, there's no relaxation, complete relaxation before another one happens. But in treppe has to do with you're applying increased frequency, but it is less than the frequency required for summation to happen. That means it's a phenomenon that has to do with increased frequency of contraction that is now leading to a higher force of successive contractions. Staircase. You know how a staircase is? Okay? So there's a contraction. Okay? Shortly afterwards, another contraction of the same muscle, okay? Another contraction happens. Shortly after, another contraction happens. The intensity, look at that's why it's going higher. The intensity of successive contractions, they are increasing. That intensity is talking about force. You know, when you draw it like this side, intensity of force over time. So it's happening very rapidly and the force is increasing. You know why it's so special in cardiac muscle? It also happens in a certain way in skeletal muscle, but mainly cardiac muscle. Very interesting is the fact that if you are doing exercise, for example, you are running, okay, you are exercising, what happens? Your heart will start beating faster. That means the frequency of contraction is increasing. But another thing that is also increasing is the force of each contraction. Do you understand? The force of each contraction is also increasing because of this staircase phenomenon. And it is very important because you need not just more rapid contraction, you also need more force, more blood to be pumped out to supply the exercising muscles of the body. Do you understand that? It's very helpful for the heart. And it's one of the things that is failing in heart failure. No, heart failure. Talk about heart failure. That means inability of the heart to pump enough blood for the body. Inability, cardiac output, that the amount of blood pumped per minute is reduced. It's as a result of the failure of the staircase phenomenon. There's increased frequency, but it is not increasing in its intensity of contraction. Okay, so heart rate is increasing, but also force is increasing. It's this trippy Bowditch phenomenon. Very important. All right, so that's what happens. That's trippy. Now let's go to the fifth one. The length tension relationship. What's the relationship between the length? This length, we're talking about the length of the sarcomere. Length tension relationship. Now let's draw something like this. Let's attempt to draw a sarcomere. Okay, so this is a sarcomere, just a very simplistic drawing. Now, length tension relationship. We're talking about how much force can a muscle generate based on the length of the sarcomere. Okay, so there's something called resting length, also known as optimal length. That is the length of the sarcomere wherein the muscle can generate the highest amount of tension or force. And this is the explanation. You know, for example, this muscle, bicep now, this is extended. It's extended fully. When I do it like this, it is contracted fully. Okay, but when it's middle, the lengths, they are different. Okay, so usually at optimal length, which for in this case of this muscle, it's at this middle point, there's higher force that the muscle can generate. And this is the explanation. Now there are three. I didn't draw three scenarios, but I just drew two, which is sufficient to explain it. What happens is that, you know, contraction has to do with the contact between myosin head and actin. This red one is the actin, okay, the thin filament, while this black one is the thick filament. Okay, myosin head contacting the actin. What happens is that there are different points at which each head can contact. The contact is called a cross bridge. Okay, so when the length is increased, you increase it like this, separate it, you see that not all the cross bridges are in contact with the actin. That means the force will be reduced. The force that that muscle can generate at that point in time will be reduced because there are other cross bridges that are just there lying fallow. Okay, so when optimal length is when all the cross bridges are making contact with the actin filament. Do you understand? So it now comes to a point, this is optimal. There's another point where it's now more contracted, closer together. The sarcomere is shorter. That means this actin like this, there are binding sites that will not be touching. These are the cross bridges of the, they are, when it gets to this point, there are sites that will not be in contact with the myosin. So either extremes reduce the force or the tension of contraction that that muscle can have. Do you understand? That's what this length tension is. So just understand it like this. With this illustrative diagram, you can understand it. It can be asked to talk right about length tension relationship in a muscle. So you do this kind of simple drawing and talk about it. Okay? So finally, let's talk about another one. It's called velocity load relationship. This one is actually the easiest, very easy to understand. Okay, let's say I carry a load like this, a dumbbell. What happens in velocity means that the velocity, the speed at which I will contract my hand or raise that dumbbell depends on the load. If I'm holding a 3 kg dumbbell, I can easily, you see the speed at which I will reach my hand will be very fast. But I'm holding a 15 kg dumbbell. What do you think will happen? I can't raise my hand very fast like that. The speed of contraction will be slower. So the higher the load, the slower the velocity of contraction. Simple logic. Okay, you are carrying load. But if you are not carrying anything at all, is the highest velocity is when you are not carrying any load at all. But you carry something like this, 3 kg, 5 kg. As you are increasing the load, the slower the velocity of contraction. That's what this is talking about. So next we're going to be looking at some of the pathologies, problems that can happen in muscles. Okay, we're going to be talking about myasthenia gravis, Lambert-Eaton syndrome, and so many other things. Different problems that can arise from skeletal muscle contraction. Very interesting, very important for you to know that the examiners ask it a lot. So we're going to see you in the next video.